moderators, and board of directors. I know it's a holiday, but we're here and we're gonna to attend this webinar lecture series. So again, as sabi ko kanina, good morning, good afternoon, and good evening for all the participants here watching this webinar as well as sa FB Live po natin. Stay safe and healthy. Let me acknowledge the presence here right now. As you can see their videos, President Bong Suero is here. Our speakers, the father and son speakers, Engineer Richard Tan and Engineer Justin Tan. Good afternoon, sirs.
Good afternoon po.
Good afternoon po.
Our moderator, panelist, Dr. Mark Zarco is also here. And we have our board of director, one of our board of directors is also here, Engineer Maribel Martinez. So present po lagi siya. And of course, ayun, andun na rin po ang ating always present na PRC chairperson, Ma'am Praxy Bernardo. Nandito rin po siya ngayon.
Hi, good afternoon.
Good afternoon po.
Hi, Engineer Richard. Hello. Nice to see you. I'm excited to be on the other side of the classroom.
Baka mapakalitan niyo pa ulit.
Okay.
Thank you po. Thank you po na nandito kayong lahat. Let me also take this opportunity again to thank the organizers of this webinar. First is the PICE ISG Interspecialty Group, the PICE Board of Directors, of course the Secretariat, the chairs and members of the specialty group. So this time it's the Geotechnical Engineering Group. And I would also like to acknowledge our corporate sponsor, Davis Paints. Yan po, sila po ang ating sponsor na ang official corporate sponsor ng PICE. So now, I'd like to turn you over to our president for his opening message.
Thank you. Salamat, Ginoong Eric Season. No?
Sure.
Iba naman tayo this afternoon, no? Because it's for Independence Day. Yeah? So, mga kababayan, kung mga inhenyerong sibil, isang makabuluhang araw ng kasarimlan o kalayaan ng ating minamahal na bansa. Magandang araw sa lahat na nandito sa bansa at lalo na doon sa mga nasa ibayong bansa na mga kapatid natin. No? Sa awa ng ating Panginoon, sana'y lahat ay nasa ligtas at magaling na pangangatawan ngayon at sa mga darating pang panahon. No? Sa ngalan ng bumubuo ng tagapamahala ng PICE National, nais ko kayong batiin sa inyong buong suporta at pagdalo dito sa ating PICE free webinar lecture series. No? So, nasa pangatlong session na po tayo. Magtatalakay ito sa Geotechnical Engineering. Pasensya na, Bisaya pa ako. No? Actually, Geotechnical Engineering ay isang bahagi ng ating spesyalisasyon bilang isang inhenyero sibil. Nais ko ring pasasalamatan ang ating corporate sponsor na mention na kanina ni Director Eric, yung Davis Paints, sa kanilang walang asawang pagsuporta sa ating mga programa ng PICE. Salamat po, Davis Paints. Pwede po siguro magbisaya sa sunod,
Pwede.
So, okay, bagong normal. Bagong normal. So, maunay Bisaya. And I hope everybody is already liking the new normal. And in PICE, we believe for now that the delivery of our continuing professional development programs to all our members will already be through online or virtual ways, such as this Zoom webinar that we are having now. PICE's main concern these days really is everybody's safety and health. No? So anyway, expect more web-based conferences, such as our future technical conferences, among other activities of the PICE, and which are already in the pipeline. No? As I've said during the past days, don't worry, PICE will not really stop serving you in providing your CPD needs as much as we can. Though I believe many were not really accommodated in the Zoom hall already, but we will try to keep on improving and making ways to have a room for everyone. Anyway, you can still view the webinar live on our PICE FB official page, Philippine Institute of Civil Engineers, Incorporated. Yun yung FB page natin, ano. And of course, don't forget to like it para dadami tayo doon, no. So today we are happy to welcome our presenter, Engineer Richard C. Tan, also with Justine Tan, yeah, who will be formally introduced later. And to talk on the topic pile testing, no, and our panelists, Dr. Mark Zarco, sir, our PIC's chair of the Specialty Division for Geotechnical Engineering. And likewise, we have also here with us the PIC National Board of Directors. Andyan lang sila lahat. And of course, our ever supportive chair of the PRB of Civil Engineering, Ma'am Praxi Bernardo. Ma'am, thank you again. So sa muli, ako ay nagpapasalamat sa lahat ng mga nanonood at nakikinig sa atin ngayon. Just make yourselves comfortable at sana ay ang ating makukuhang kaalaman ngayon sa araw na ito ay makakatulong sa ating practice ng ating profesyon. Okay, so maayong hapon sa tanan. So Director Eric, ikaw na.
Salamat, Pres. Pinahirapan mo naman kami magsalita ng Tagalog niyan, pati ang ating mga speakers. So, ano muna, house rules po muna, house rules muna po tayo. Paki-share na lang muna, EJ. Ayan, so hindi ko na ho tatagalugin ang house rules. I-discuss ko na lang sa inyo kung ano ang ating proseso during this webinar. So, number one, again, this webinar relies on the quality of your internet connection. So it is suggested that you close all applications, especially those using the internet or in your household or office. Holiday po ngayon, so malamang nasa mga bahay po kayo. So if you could close all other apps or even yung iba pong gumagamit ng internet to maybe for at least 2 hours to just turn off their internets para po mas ma-appreciate nyo itong webinar na to. Second again, the audio and video of all attendees are muted. So this is for the participants to focus on the presentation as well as the speakers not to be disturbed. All questions shall be posted on the Q&A box. So it is below your screens, meron po ron chat box and Q&A box. Yung questions po na gusto nyong itanong sa presenters natin or sa PICE, doon nyo po sa Q&A, wag po dun sa chat because sa chat po, after a while, hindi na ho namin mamomonitor with all the messages coming in. Sa Q&A po kasi may tracking po siya so madali ho namin mamomonitor yon. The Q&A will be screened by the panelists which is Dr. Zarco and myself, and then after the presentation, it will be asked to the presenter. So after na lang ng presentation po. Other questions that are not addressed during this time, you can email it in the email below, zoomwebinar.pice@gmail.com, and hopefully we will be able to answer it via email soon din po. Okay, so again, as Pres Bong said, medyo limited lang din po yung ina-accept namin sa webinar. We only accept about 500 participants. So yung iba ho na hindi na ho naka-register can still watch it through our Facebook page. Naka-broadcast po tayo live, and just search po yung Philippine Institute of Civil Engineers Inc. Make sure you search the whole thing because marami pong web FB page na may PICE, so make sure you go to the official web page. So it will be broadcasted there. Now a poll evaluation form will pop up your screens right after the closing remarks later or after this webinar. May magpa-pop up po sa screen nyo. So it's a 10-question survey lang po about the webinar, the speakers, the moderators, and the topic as well. So please fill it up and submit before you leave this webinar. So may lalabas po dyan. Just in case hindi lumabas, again, below your screens, kasama po ng Q&A chat icons, may lalabas po dyan na poll na icon just in case hindi po mag-pop up sa screen nyo. Just click it and then fill up and submit that form. Now, with regards to the certificates, again, only PICE members who have successfully attended, registered, and attended the webinars will be given a certificate which can be used later on for dun sa CPD accreditation or CPD points natin. So as well as the lecture materials, it will only be provided to those who have attended that topic, kung anong topic po. Now, dun sa hindi pa po nakaregister as members sa PICE, then again, there's a link there. Please sign up and become a member of PICE, pay the corresponding membership dues, so you'll become a member, and so you'll be able to receive those certificates for these free webinars and also the materials. The certificates and links will only be posted right after pa po ng webinar na to, which is until June 19. Hindi po siya i-email sa inyo, hindi rin po siya ibibigay right after, a few days after the topic, but it will be uploaded on the membership portal or PICE website after the last day of this webinar. So dun nyo lang po i-access. So that's why you have to be a member. So only members can access the web page. So please become a member so you can access the web page and download all the certificates and materials for this webinar. And so I guess that's it. So I'll turn you over to our moderator today. He's our chair of the Geotechnical Engineering Specialty Division of PICE, also professor in Institute of Civil Engineering, University of the Philippines. I think marami sa dito mga naging professor na rin namin dito mga speakers, saka ako rin po naging professor ko rin po si Doc Mark Albert Sardo.
Okay, thank you, Eric. And new normal. Okay.
New normal.
Okay, so I'd also like to thank Dr. Suero for inviting the Geotechnical Engineering Division to be able to present this new and this webinar on pile testing. So our speakers, we have two speakers for today. Our primary speaker is a very good friend of mine who I've known for more than 20 years. He's Engineer Richard Dunn, who's currently the president of AGES, or Advanced Geotechnical Engineering Services, which is based in Fairview, Quezon City. He has a Bachelor's of Science in Civil Engineering from Mapua and a Master's of Science in Civil Engineering from UP Diliman. Together with him is his son, Justin Tan, who holds a degree actually in mining engineering. But both Richard and Justin are certified by pile testing. Justin in particular has expert certification in dynamic pile testing. So he's one of the few people with expert certification in dynamic pile testing. So Richard has been in the business for, I think, more than 30 years or 40 years. And so he's highly experienced. He's also a member of the specialty division of PICE, the Geotechnical Specialty Division of PICE. So I would like to turn over the floor now to Engineer Richard Tan and Justin Tan, who will give the webinar this afternoon.
Una, magandang araw sa lahat at Happy Independence Day. Mukhang marami akong nakikitang senyales ng ating kalayaan. Isa na yung book ni Dr. Arco, mukhang naging malaya. Now, I think pagpatuloy pagsasama ng bansa dahil Independence Day naman. Hindi ko alam kung mas preferred ng iba Bisaya. We can accept questions in Bisaya if you like. Versat dahil ang mama niya is a Bisaya. Now, i-divide ko lang ang presentation namin into two parts. No? The technical part, and I will just discuss yung maybe non-technical na dapat pag-isipan, I would say. No? Okay, so for example, ang unang gusto kong pag-usapan is why the need of testing? Who needs testing? So I'll just go through every topic siguro briefly, even without giving some answers, para lang mag-isip ang mga participants. And later on, if you want to discuss these issues, then we can talk about it sa Q&A. Bakit kailangan ng testing? Well, number one, ang madaling sagot doon is safety. Pero safety, madali naman magtayo ng building or any structure na safe. Dagdagan mo lang ang pilote, safe na yan. Katulad ng ginagawa siguro noong araw. So, more than safety, I think as engineers, we want to come up with the most economical design or foundations. Another issue related to that is yung pile capacity. We need to validate siguro yung mga design parameters, the integrity of the pile, kung kaya natin kailangan mag-testing ng piles. Now, oftentimes, we were asked the question like, well, we did soil investigations already. Ba't pa natin kailangan mag-testing ng piles? Hindi ba sigurado na tayo pag alam natin ang lupa? Well, hindi ganun kadali, no? For example, for board piles, well, pile capacity, for example, is being derived through soil investigations. Pag alam mo yung lupa, then pile capacity, pile length, and others. No? However, sa board piling, it can be shown through practice na the pile capacity is also dependent on the workmanship of the board. Pag halimbawa, may defect ang pile, nagtagal ang pouring, nagkaroon ng thick lining doon sa perimeter ng pile, maapektuhan ng skin friction. So, pile capacity for board piles, for example, I would say is not only dependent on the geotechnical parameters, but also on the workmanship of the contractor. Now, for driven piles, kaya tayo nagte-testing is number one, of course, babalik ka pa rin sa pile capacity. You are validating the pile capacity. But more than that, you are also trying to validate, for example, the pre-stressing pressure in a driven pile. Often we talk about pre-stressed piles. Parang automatic na yan. When you order driven piles, it's always pre-stressed piles. No? Pero seldom would I hear anyone asking what is the required pre-stressing pressure? Why do we need pre-stressed piles? So, ito yung mga bagay-bagay na you need to know because if you neglect all this strength, baka it may lead you to some catastrophic incidents. No? And basically, ganun siguro ang patutunguhan. And then another issue that we would like to discuss at length, maybe if we have time, would be the application of wave equation analysis. No? Why do we need to do wave equation, or when we need to do wave equation? So, Ang wave equation is the sole basis of dynamic testing. In the olden times, in the 80s, wala pang masyadong testing because ang testing naman nabuhay yan because of microcomputers. We only should predict file capacity, blow counts, stresses in the file. Now, ang isang gamit ng wave equation, for example, now, would be yung mga tinatawag na drivability analysis. No? If you have soft soil, and then suddenly meron kang stiffer soil, and then underlain by another soft soil, for engineers, pag dinadrive ko itong file na to, will I go through this dense soil and into the soft soil again? Or will I get stuck into that dense material? And geotechnically speaking, would that be possible? Would that be plausible solution? Or do I really need to go through this dense material? If I do, then what kind of hammer do I need? What size of pile is ideal for this purpose? So all these things will be answered by the wave equation. Wave equation is nothing but of the entire driving system, no? From the hammer to the cushion to the pile and to the soil properties. You model everything, and then you it's like looking at the pile driving system through your computers. If you have the right parameters, then you probably will get into the right numbers that you would be needing. No? Ganun po. Now, maybe we should also spend more time on the Q&A based on the topics na gustong malaman ng mga participants natin. I can see we have about 160 participants, so I'm sure maraming tanong ito. So, without much ado, I would like to give time already to Justin because yung presentation niya about testing and what you can see, mahaba yan. So, I'd like to pass the mic to Justin in a while. And kung merong Q&A, I'll just be part of the panel siguro to answer the Q&A. Okay, Just.
Hi, hello, good afternoon everyone. Malinaw po ba yung video at mic ko? Can I get a confirmation from somebody just to make sure?
Yes, sir. Sir, malinaw naman.
Okay.
Yeah. Video and audio is okay.
All right. So I think I'm supposed to share my screen, no, for a presentation, or does the PICE have it? Thank you sa mga nang-confirm na malinaw on the chat box. So is it okay? I think I should share my screen, no, para you can see the presentation. Okay, anyway, yeah, sige, I'll just go ahead and do that. Okay, so I think the objective, I'm not sure what screen you're seeing right now. Okay, all right, good, thank you. I'll go to the full screen. Pero I think, if I'm not mistaken, the objective of our presentation today is to give an idea of what pile testing is, what's the importance of pile testing, and I guess the different methods of pile testing. Is everyone, I'm not sure if everyone is seeing the same screen, but we should be on a screen where it says pile testing in green. Is everyone seeing that screen?
Hello?
Okay. Is everyone seeing the screen? Can I get a confirmation just to make
Wait,
sure?
I'll mute muna dito.
All right. Okay. Thank you, everyone, for the confirmation. Medyo madaming yes. All right. So, okay. Earlier, my father was talking about the wave equation and drivability. This is actually one of the I guess subsets of pile testing. This is really going into that discussion. I would say is going down the rabbit hole of pile testing. And please do not be overwhelmed with the things he was saying earlier. I'm the dumber version of my father, and I do my presentations where I assume that my audience are, not so experienced or doesn't have that much background about pile testing. If you want a more educated and highly technical discussion, then that would be my father. Again, I'm the friendlier version, no? The easier to listen to. So okay, let's go to pile testing. Siguro let's just skip this because this is just a company. That was more of a company. But no, let's go back to that because I want to show you how how long my father has been doing pile testing. So he has been doing pile testing since he had black hair, and as you can see now, that's not the case. So okay, basically the objective of pile testing is to is an assurance for the quality of the foundation element. I mean, we all know how important foundations are, the piles are, right? Because this is what carries our structure. This is what we're relying on when there's an earthquake, when there's a seismic event. And it would be remiss not to check the quality of our foundation. And that's why this is included, no? And this is included in the specs, in the requirements. This is an essential part. And the reason why we test is because in a project, we can't expect all piles to be installed perfectly or made perfectly. As you can see here on the picture, basically we have two common kinds of piles, especially here in our country. So we have the board piles, which is made at the site, casted in the site. And we have the driven piles, which are the precasted piles that are brought to the site and subsequently installed. So as we can see here, these are actual photos that we took showing that not all piles are made equal. Just like just like I guess humanity, not everyone is made equal. But this is not so uncommon to see piles that have defects and that have damages. And this is where the importance of pile testing comes in, is because you want to make sure that your foundation elements are safe and can support the structure that you will be putting up. So I actually made the game, just a few slides. This picture, I guess, is not so clear, but if I zoom this in, this is the pile. And oh no, I just revealed that. Okay, so I was supposed to ask you if you think this pile has a defect or not. So, well, it has a defect, obviously, from this picture. So this is how the game goes. So again, I'll show you another picture of a pile, and you try to guess mentally. Sorry, I have no prizes for those who can guess right. But you can try to guess mentally if this pile has a damage or not. Okay, so again, this is a picture of a pile, and I covered the bottom part of the pile so you guys can make an educated guess whether this has a damage or not. So I'll give you 2 to 3 seconds to try to make a guess. All right, okay, so for those who said no, well, I'm sorry to say, but this pile has some sort of defect right there, as you can see. If I zoom it in, are you also able to see the zoomed in portion from my screen? Okay, thank you for that confirmation. So as you can see there, it has quite a terrible cavity there going on. And you might wonder how in the world this pile was able to sustain that kind of damage, given that this is a precast pile, it's a drip pile, and these piles are made in the factory, and you can see visibly before they're installed on the ground, you can see visibly if they have some sort of damage or not. And so you might wonder, how in the world is this possible? Is there, is there an animal down there that eats up the pile or something? Well, to be honest with you, sometimes I also don't know the answer as to why. I can only make educated guesses. So for this one, I would guess that this pile was damaged previously before it was installed, and maybe it was just not reported, or perhaps this was damaged after it was installed. Sometimes at the site, space is not so abundant, and you have heavy equipments going around the site. And I've seen one in the past where a crane hits one of the piles, actually, that's sticking out of the ground. And while we may not see the consequence of that, of the crane hitting the pile, but it can actually crack your pile under the ground, no? Under the segment of the pile buried under the ground. It can it can it can develop cracks when it's hit by something like, for example, a heavy equipment. So I've seen that actually in the past. There was one site where it was a bit crowded and there were piles sticking out of the ground, and this crawler crane was trying to maneuver its way around the site, and in doing so, it hit one of the piles. And I suggested that we test that pile, and so we did, and we found some damage on the pile. So those are the things that can cause damage to piles. Okay, this would be the last for our game today. I would like you to guess if this pile is okay, because the reason why I cover the lower part of the picture is because at the site, this is what you see. You only see the ground in the upper portion of the pile. You do not see whatever is going on underneath because it's covered by the ground. There's no way for you, unless you're Superman and you have X-ray vision, to see what's going on and find out the defects. So this is the last picture. This is probably my favorite picture. I think I'm giving the answer away, and the answer is yes, it has a damage. And let's see. Wow, it's it's quite disturbing actually. Imagine not testing this pile and assuming that this was okay, and you put your structure here, you put your condo here. I mean, that's something that is quite. I don't know. I don't know what to say about that, but it's quite disturbing for me. And so I think I've already emphasized why testing piles is quite crucial and quite important. Okay, so let's now go to the different methods of testing piles. Of course, we have different ways of testing piles and different objectives. But let's start with this one. Let's start with the Crosshole sonic logging test. For those of you who have been assigned to projects with board piles, you might have seen this test before. So basically, the Crosshole sonic logging test is a test that determines the integrity of your pile, of your shaft. Take note that when we say integrity, we're talking about the quality of your pile, meaning if it has defects through soil inclusions, through cavities, through dirty concrete. So when we say integrity, we're talking about the quality of the material in the pile. So this test essentially is to determine the integrity of your pile. Also, I would want to note that this test can be done only on board piles. Later, I will explain why this is only done on board piles. It has something to do with the preparation of the test. That's why this is only done on board piles. Okay, so this is a let's say a lengthwise, is that correct? A lengthwise section of what a crosshole sonic logging looks like. This is the diagram. Let's go to this diagram first. So let's imagine cutting the pile along its length, along its longest axis. So what we see actually are the steel tubes actually are installed together with the rebar cage. So for example, we have a pile of a certain diameter and we want to conduct the crosshole sonic logging test. We would install steel tubes on the pile all throughout the length of the pile. So this circle here is a top view. This is the top view, and we have 4 tubes on the pile. Of course, depending on the diameter, of course, the larger the diameter, the more tubes you would have so that you would cover more area. But okay, let's just use this as an example. So we have 4 tubes on the pile. And then the tubes again run from the top to the bottom of the pile. So basically what we're doing is we have a transmitter probe here, the blue one, and the receiver probe, the red one. Okay, so essentially what we're doing is we're collecting ultrasonic scans all throughout the length of the pile. That's what we're doing with the crosshole sonic logging test. So going back to the top view where we have 4 tubes on the pile, what we do is we cover all the combinations. We cover all the combinations of the tubes. So for a 4-tube pile, we would have six scans. If you count it, if you count all the possible combinations there, you would have 6. So what we do is we scan all those 6 to have a good idea of what's going on, what's going on in our pile. Is there a defect in our pile? Is there some sort of flaw in our pile? So we cover all that 6 combinations and we run the test from the top of the tube to the bottom of the tube, which is essentially the top of the pile and the bottom of the pile. So now, how does this test work? How does it determine if you have, let's say, dirty material in your pile, or if you have voids on your pile, on your board pile? Okay, so just to, hopefully I can explain this properly, the concept properly. It's actually quite simple. So what happens is the crosshole probes, one of the probes, the transmitter emits an ultrasonic pulse, okay? And that ultrasonic pulse has a certain speed for a certain material. Meaning if I have concrete, that speed would be somewhat more or less very constant for concrete. Now, if I have a different type of material, let's say I have soil or I have air, then that speed would be different because they are not the same material. Okay? And so this is what the crosshole sonic logging test does, is it detects any change in material, because your assumption is when you have a board pile, your assumption is that this pile contains only concrete all throughout my cross section, correct? By the way, for those who are not yet so familiar with board piles are constructed at the site, and you do this by drilling a hole on the ground and putting the rebar cage, the reinforcement cage, and pouring concrete. So sometimes on the streets, if you see a lot of concrete truck mixers lined up, they're probably, it's either they're doing the superstructure, but if there's no superstructure there, then they're probably constructing a board pile. So that's one of the telltale signs of the construction of a board pile. If you see a lot of concrete rock mixers lined up outside and there's no superstructure yet, then they're probably constructing piles. So that's how a board pile is constructed. So again, the assumption is you have concrete all throughout your cross section, right? But of course, we know Mother Nature just doesn't allow us to construct perfect piles all the time. Of course, sometimes the soil collapses somewhere along the length of the shaft. Sometimes the concrete rock mixers, there are delays with the concrete rock mixers, and so you develop some cold joints. There's all sorts of problems, of course, in reality that comes with constructing, that comes with the construction of a board pile rather. And so the assumption that the board pile should only contain concrete in reality is not true. Of course, again, like I said, you can have soil inclusions and you can sometimes even have voids. And so having those in your board pile would give the material in your board pile some inhomogeneity, meaning it's not homogeneous, it's not one material anymore, it's not just concrete. In certain cases, it's sometimes there's some soil inclusion on it, and doing the crosshole test, the crosshole test would be able to detect the change in material in your cross section. And so essentially that's how the crosshole sonic logging test works. It detects a change in material. Okay, is that clear? By the way, if I think we're supposed to have a question and answer portion, but my style, a question and answer portion at the end, but my style in doing presentation, sorry if I'm violating the rules and the regulations of how a presentation is to be conducted, but I prefer questions in the middle of the presentation so that, because this happens to me in school. Sometimes the professor is too smart for me and they're discussing and I get left behind, and it's hard to get left behind and not understand what's going on for the rest of the class. And so likewise, if there's some confusion in my explanation or if you want something clarified, just please type it in. I'll try to look at the chat box as often as I can. And I'll try to answer the question just so everything is clear and we're on the same page and nobody gets left behind. Okay? Oh, it doesn't want to go to the next. Oh, there we go. Okay. I included this picture actually because this is actually more for the structural engineers that are listening, because of course they come up with the design, the rebar design for the pile. And sometimes, yeah, we create our own problems because sometimes we have too much reinforcement that, I mean, how can concrete flow out of the rebar cage and cover the outer part of your pile? You know, have a concrete cover on your pile if you are too heavily reinforced. So I've seen piles like this, especially for long piles with that are connected in segments, the splice segments. Yeah, sometimes the reinforcement is too much where I can't imagine how the concrete will flow out of that portion. So I guess this is something that maybe the structural engineers, the designers can also consider in their design. You have, of course, you have to check the size of your aggregates, and you have to, of course, check the spacing of your vertical rebars and make sure that the aggregates would pass through. Of course, we want some concrete cover on our board piles. Okay, so these are actual pictures of the crosshole sonic logging test. So this is more for showing you pictures of how not to prepare, how not to prepare for a crosshole sonic logging test. Of course, we don't want the tubes too high because it would be difficult for us to put our probes there, lower it down, and pull it back up. At the same time, we also don't want the tubes to be too low for the reason of we have to constantly fill it with water. By the way, when we test for the crosshole sonic logging test, we put water on the steel tubes. We make sure it's filled up with water. So it's one of the requirements for the test. And yeah, these are not so ideal tube preparations. But anyway, these are photos showing you just so you can imagine an actual photo of how a crosshole sonic logging test looks like. Okay, so this is another example of this is us really doing the crosshole sonic logging test. I'm just gonna go skip this part because this is more for the preparation. Basically, what we're doing is just we're making sure we have a dummy probe. This is not the actual probe, by the way. This is just a dummy probe. We before doing the test, before putting in the real probes, we put in a dummy probe just to make sure that there's no blockage on the tube, because the last thing we want to happen is for our real probes to get stuck in the tube and not be able to retrieve it. So we are all gonna cry if if that happens. So we always make sure that the tubes are free and accessible. So let's go to the next slide. Okay. Well, not me, but somebody took a picture and I included it here. I think it was one of our engineers, our senior pile test engineers, and I think she's also listening now. Hello, Maureen. I think she was the one who took this picture. And this basically shows you what the crosshole sonic clogging test looks like from the computer screen or when doing the actual test. So again, like I said earlier, going back to the concept of the crosshole sonic clogging test, given that, or what I mentioned was, this was a test of how homogeneous your material is, because again, it detects any change in material. So this screen actually, or this graph actually, tells you how homogeneous your material is. If we zoom in on this, what we call the waterfall diagram, this green and black color that you see on the screen is what we call the waterfall diagram. And basically, this is a compilation of the data points all throughout the length of your shaft. So as you can see here on the right-hand side, you have 6, 7, 8, 9 meters. So that's the indication of how deep we are, how deep our probes are into the pile. And we're doing this from the bottom up, by the way. That's why on the shallower depths, you still don't see the waterfall diagram. But basically, the waterfall diagram, basically, this is the arrival time of that ultrasonic pulse. Again, the ultrasonic pulse travels through your concrete, and of course, we know the distance between tubes, and we can determine the arrival time. We can determine the arrival time of that ultrasonic pulse in concrete. And as you can see here, just imagine that the x-axis is your time, okay, and y is the depth. So if x-axis is the time, then we can say that we have a uniform arrival time, correct, of the pile. Because as you can see here, the waterfall diagram here creates a vertical green and black graph of color, correct? So again, x-axis is the time, and you can see we have a vertical diagram. That just means that we have a uniform arrival time, which tells us that we have a uniform material all throughout our pile. So, well, I mean, in simple words, that's exactly what crosshole sonic clogging test is. But let's go to an example where we detect some change in material. And that's where the crosshole sonic clogging test becomes interesting and quite tricky. Okay, so as you can see here, if we look at the waterfall diagram. Okay, sorry. So there's a comment here by Doc Zarco. State the diameter of the sounding tubes are, okay, someone is asking if you can perform a CSL on a micropile about 0.4 to 0.6 meters. Yes, of course. You can perform a CSL, or this test, a crosshole sonic clogging test, on a micropile. So the size of the tubes, actually, I would say that the minimum should be about 1.5 inches. That's about, if I'm not mistaken, 37.5, something like that, 37.5 mm. But usually what's being used is 50 mm. So anywhere between from 37.5, 1.5 inches to 2 inches size of the tubes are what's used for the crosshole sonic clogging test. So for those who are wondering what tubes are, again, let me let's zoom in on this picture. So these are the tubes there. So these are there. That's a better photo. So yeah, those are about 1.5 inches to 2 inches. And yes, you can conduct the CSL on a micropile that's 0.4 to 0.6 meters. So I think for a micropile that size, I'm not sure if you can still fit 3 tubes there, but 2 tubes should be okay. But I mean, it's better to have 3, because 2 tubes, you only have 1 combination of scan. And that's really, I mean, it wouldn't really tell you, it wouldn't really give you a nice idea of the quality of your cross-section, because you only have 2 tubes. Okay, so let's go to this slide. All right, so again, this is where the crosshole sonic clogging test becomes tricky, is when you have the change in material. And of course, when you're doing the test, the only thing you're seeing is the waterfall diagram. Of course, so this was an actual test that we did, and so we did it, and then we found some, we call it the first arrival time delay, or basically it's the time delay. It's a delay in the arrival of the ultrasonic pulse. Any change in the arrival would tell you that there's a change in material, right? Going back to the concept. Okay, so we did this test, and we told the client that, hey, we think there's some problem here. Of course, I mean, when clients hear that, or when contractors hear that, of course, they're a bit, they have some reactions to it. And sometimes they don't believe, or they don't want to believe. And so what we said was, okay, let's just core the pile. So for those who are not so familiar with coring, coring is basically drilling the pile and getting the samples that you have drilled. Okay, so basically what we said is let's core the pile. And so these are the actual samples actually on the left side. As you can see, this is not the type of material that you want in your pile. So this is actually, yeah, this is the actual sample for this pile that we did a crosshole sonic clogging test on. All right. Okay, so this is another example. As you can see, the signal was a bit weakening, right? The color is not so, it's not so striking anymore on this segment. And so what we said was there might be a problem there. There's probably a problem there. So let's go and investigate, and let's core. And when we cored, this is the samples that we got. Okay. Let's move on to the next slide. Okay, so this is another example of, this is actually very tricky because it's a very thin lens of signal delay. And so one might argue that, oh, this just might be a random signal loss, although it depends. And in this case, it's actually quite severe. So we did the test and we saw this, what seems to be a thin lens of signal loss. Turns out to be, I want you to focus here on the sample actually that we took. So if you can see here on this left hand side, from 11 to 11.7, this is actually what you want your concrete to be. It's intact, it's solid. And so this is actually a perfect example of good concrete, of good quality concrete. And this is about 0.7 meters long, okay? And now let's go to the right where we detected this, again, this signal loss. And once the coring reached that part from 11.7 to 12.7, you can see that the sample they retrieved is very much shorter than the sample from 11 to 11.7. And so this is supposed to be actually a 1 meter sample, but all you're retrieving is, I don't know, maybe about 0.35 or 0.4. And so imagine 0.6. 0.6 of your sample is gone, is missing. And so what does that tell you? Well, to me, that tells me that there's probably some weak material there that's not concrete, that's probably dirty concrete that got washed out during coring. It's not strong enough to survive or to endure the coring and be taken out and be seen as a solid sample. And what you have here is a very terrible case of a defect in a pile. Okay, oops, I'm so sorry. Let's go to the next slide. I'm having a, okay, so this is another example. This example was quite shallow. Well, not so shallow, but I guess shallow enough for them to dig it out and see what was happening. And so this was the result. Okay, anyway, I think we already get the picture that if there's any break in color in the graph, that's not a good sign. Okay, so this is actually, so we can actually do an analysis. We can actually take cross-sectional slices, for example, from the Crosshole sonic logging test, because it would be hard to sort of imagine what the cross-section of my pile looks like from this, from looking at waterfall diagrams. And so one of the things that we can do is we can compile the Crosshole sonic logging scans and turn it into something like this, which is a cross-sectional slice, telling you how much of your cross-section has good concrete and how much of your cross-section isn't so good. And so just to discuss this quickly, we, for example, in this cross-sectional slice, it says the depth at 4.4, you only have 67% effective area, meaning in my cross-section at 4 meters, at 4.4, I only have 67% good concrete, and the rest of it is questionable or not so good. All right, let's go on to the next test, which is the pile integrity test or the low strain integrity test. So the low strain integrity test, as you can see on the photos, you can do this on open piles. You can also do this on board piles. So again, this is an integrity test, meaning it checks if your pile has major defects or not. So what's the difference between PIT and Crosshole? Again, Crosshole, you can only do this for board piles because you need the steel tubes. You need to install the steel tubes on the rebar cage. But for the pile integrity test, you only need to access the pile top. As you can see, we're striking the top of the pile with a handheld. I'm so sorry about that. We're striking the head of the pile with a handheld hammer. And you can see this sort of device here with a wire. That's the accelerometer. It's basically like a stethoscope of a doctor. If I were to make an analogy between the Crosshole and the PIT would be like a general checkup. It would be like a rapid test if we were to make an analogy in today's context. It would be like a rapid test. And the Crosshole would be a more stringent test, a more meticulous test. So if I were to make an analogy, again, it would be like an MRI, perhaps. Crosshole would be an MRI, and the PIT would be like a doctor's quick checkup of stethoscope and whatnot, and blood pressure, perhaps. Okay. Again, the objective of the pile integrity test or the low strain is to check if your pile has major defects. This is much easier to do, as you can see. Doesn't need that much preparation aside from exposing the top of the pile. Okay, and so these are photos where the pile tops are exposed and we are conducting the PIT test. Well, this is a photo of what not to do or how not to prepare your pile for a PIT test. This picture shows you that this foundation element, this pile, is already in contact with the ground pavement or the lean concrete, right? And this is not so ideal actually, because let me first explain, by the way, let me first quickly explain the theory of how the PIT test works so that we can better understand why this photo on the left is not a recommended preparation for a board pile. Okay, so let me try to explain the PIT test in a way where everyone can hopefully understand how it works. So again, we have a small hammer, and we have a small accelerometer, the thing that has a wire and that's connected to the machine or to our monitor. And so basically, that's why it's called the low strain integrity test, is because by hitting the top of the pile, by hitting the pile top, basically, I just repeated that, you're inducing a low strain, a low impact, a low strain from that impact, okay, from the hammer, from the handheld hammer. And so that strain, that very tiny, small strain, actually travels down your pile. And the moment it encounters some defect, that strain, or that stress wave rather, that stress wave reflects back up when it encounters some defect on your pile, as you can see on this diagram. So again, we're inducing a low strain through the impact of a hammer, and then basically what we're doing is we're creating a stress wave that's traveling down the pile. And again, that stress wave, when it encounters a defect, let's say, for example, a necking, or for example, let's just say this defect is a void, okay? So any change, again, here we go back to the any change in material. So because that's essentially what integrity, just really change any change in your material. So again, when this stress wave encounters a change in material, whether it be a void or it be broken concrete or it be soil inclusion, then that stress wave, a part of that stress wave gets reflected back up and it gets recorded to the accelerometer. And so that's how the PIT test works in essence, okay? So it's through the stress wave, knowing that there's a change, and it tells you that there's a change at that depth. So likewise, it also works. So let me use a pen here. I need my magic pen. Let me use a pen. Hold on. Oh, here we go. So likewise, there we go. Everybody can see what I'm drawing, right? This green rectangular thing that I'm currently shading. So I hope everyone is seeing this. So let's just say that in my pile rather, that I have a bulge, okay? A bulge meaning an enlargement in the cross-sectional area. So maybe perhaps during construction of the pile, that segment of my pile became bigger for some reason. Okay, so let's just say that this segment of my pile becomes bigger, the cross-section becomes bigger. And so now when I conduct my PIT tests, let's say I'm here, let me draw myself here, holding this disproportionate size of a hammer, which is supposed to be handheld. If I hit this pile top, I'm gonna generate that stress wave, okay? So let's generate that stress wave here, and it's gonna travel down my pile. And what I said earlier, that this stress wave is my friend, and it tells me if there's any change in material or any change in my cross-sectional area. Meaning, if I have a cavity here, let's go down here first to the defect. Let's say I have a cavity here. If I have a cavity here, this stress wave that travels down, again, part of it gets reflected back up, and it gets registered into my accelerometer, which I determine that there's something going on there that shouldn't be. Likewise, if I have a bulge or an enlargement in cross-sectional area, when I hit the pile top and generate my stress wave encounters this enlargement. So it goes down the pile and then it encounters this enlargement, right? Because I have an enlarged cross-section here. And once it encounters this enlarged cross-sectional area or the bulge, it gets reflected back up here on my gauge. And depending on the magnitude of this bulge, depending on the magnitude, it would dictate whether that stress wave will be completely eaten up because of the size of this bulge, or would it still continue down and give me information for the rest of my shaft? Okay. Whew. Is everyone still following? I hope that wasn't too boring explaining how the PIT test works. Because let's try to answer why the picture on the left side isn't a good practice in terms of preparing the pile for a PIT test. So, okay, let me just clear up all the mess that I made here and let's go to this picture here. So can you now guess why this setup where the pavement or the lean concrete being in contact with the pile isn't conducive to conducting a PIT test? Can anyone sort of connect the dots and guess? Okay, let's just do this mentally because there's 163 of us here, and this might turn very chaotic if everyone starts speaking. So what's happening here is that essentially you're creating a bulge on your pile. This pavement is in contact with your pile, and it's sort of creating a bulge, an artificial bulge on your pile. And so what happens when, and as you know, this is a pavement, meaning this is a big bulge. This is not just a normal bulge that sometimes we refer to as nagbubuntis yung pile. But this is a pavement. You're talking of, several meters long in all directions. And so this is quite a sizable element as well. And so what happens here, if you do the PID test, you're generating the stress wave here at the top, and then once it reaches this pavement, this pavement just eat all that energy. It's gonna eat up all that stress wave, and you're not gonna be able to tell the integrity of your pile. Anything below this pavement, you're not gonna have any information on that because, again, this pavement is just eating up all that energy, all that stress wave that you've generated from your hammer. Okay, there's a question here. Let's answer this very quickly. How does the pile length and concrete strength limit the capacity or the reliability of the PID? Okay, so concrete strength actually doesn't play any role in this, okay? When you say reliability, limit the capacity or reliability, okay, so I'm assuming what you mean here is that how it affects the accuracy of the test or how doable the test is. Okay, so again, concrete strength doesn't really play much of a factor because, for example, if you have a pile, of course that pile is made out of only one designed concrete strength, correct? And so let me answer the first factor, which is the pile length. The pile length can actually have an effect, or it can actually pose as a limitation. This is a very good question, by the way, from Mr. Angelito Monte. Very good question. The pile length actually can play as a limiting factor to the PID test. Again, you're generating the stress wave through a handheld hammer. So what I'm trying to say here is that it's very weak. The energy, the impact that you're generating is very weak. And if you have a very long pile, let's say you have a pile of about 40 meters onwards, that impact energy might not be able to reach the bottom of your pile, or it might not be able to go that deep because, again, the energy gets eaten away. Of course, as it travels down the pile, of course, the energy gets gradually eaten up or consumed. So pile length determines. Now, if you ask me what the limit is for the pile length, there is no clear answer for that. That's still case to case. The best thing you can do is to try and test the pile and see what happens, because sometimes the stress wave pushes through, sometimes it doesn't. Sometimes it's able to travel the entire length, sometimes it doesn't. And this also has something to do with the resistance of the soil. If your soil resistance, meaning if your soil is hard and if it helps a lot with the capacity of the pile, the energy also gets dissipated through having a high soil resistance. One of the limits also of the PID is the diameter. Okay, it's not mentioned here in your question, but one of the things actually that limits the PID is the diameter. So having a very large diameter impairs, I wouldn't say that the PID test would be inaccurate, but it impairs the accuracy of the PID test. So when I say large diameters, we're talking about, I would say 2.5 meters, anything north of 2.5 meters. So in that case, I would suggest to just do the crosshole sonic clogging test, especially for board piles. For board piles having that large of a diameter, I would suggest using the crosshole sonic clogging test. So PID is perfect for smaller piles, especially for driven piles. This is very perfect for driven piles in terms of having a sense or getting an idea of how good your splice location is, especially if your driven piles are connected into 2 segments or more. The PID test would be a very great tool to tell you the condition of your splice for splice piles, for segmented piles. Okay, let's. I know that the the invitation says 3 to 5 p.m. So we might overextend here, overstay our welcome in this seminar. But we will try to, I'll try to quicken up, to hasten up. So these are just photos. Let's skip that. And let's go to the PDA test. I think this is the most popular test out there. And the reason why it's popular is because it gives you a lot of information about the pile. So not only is it an integrity test, meaning not only is it a test where you check the quality of your pile, but it also tells you the capacity of the pile. So when we say capacity, this is the load-bearing capacity of the pile. This is the ability of your pile to carry load. So how much load can my pile carry? That's what this test answers. And that's why this is very popular and very important, because as we know from doing soil investigation from Geotechnical, we can come up with the pile capacity. But these are based on equations, right? These are based on what we learned in school. And how do we really know what is the actual capacity of my pile, right? And so the only way to find out is to test it. And that's why PDA test is quite popular, because of course, everybody wants to know, especially the structural designers, they want to know if the design assumptions are indeed correct, or are indeed, if the design assumptions and my actual pile are indeed the same, or perhaps better, or in worst cases, I guess, worse. And so that's why you test piles, because you want to find out what's the actual, that's why you test with PDA rather, is because you want to find out if my pile can actually carry the load I'm expecting it to carry. And if it can carry more, then perhaps maybe I can value engineer. But if it can carry less, then that's good, because at least I can adjust my design and come up with a safer and more appropriate design. Okay. One of the things, this is, as you can see here, there's a checkpoint here that says hammer performance. The reason why it can also tell you about hammer performance is because if you're using an impact type hammer, one of the things that the PDA test does is it measures the energy of that impact. And by measuring the energy, you're able to tell the efficiency of that impact type hammer. Okay, I don't want to go too detailed about this because I feel like I'm gonna lose a lot of you guys. So let's just focus on the pictures so I can give you an idea of how the PDA test is done. So essentially, the PDA test is called the high strain dynamic. This is actually the high strain. Well, there's many names, but this is a high strain. I want you to focus on the high strain. Now, earlier PIT was low strain. Again, low because you're only using your hand, your muscles, the human muscles, to generate the stress wave. But with the PDA test, you're using machines. You're using quite a sizable hammer. So this element here, this cylindrical element here, as you can see, is a hammer. And of course, this is what we drop on top of the pile to generate, again, let's go back to that stress wave. So yeah, we use a hammer, a very heavy hammer, to generate the stress wave. And again, that stress wave tells us, like with PIT, it tells us the integrity. But this time, aside from integrity, since we're generating a high impact or a high energy drop, a high energy impact, we're generating a high stress wave, a high strain stress wave. And so what this does is it also gives you information. That's where you get the information of the capacity of the pile, of the ability of the pile to carry load from that high strain or from that high impact stress wave. Here is another picture of another type of hammer, and this is your pile here, down here, quite camera shy, not showing itself. Whoops, I'm so sorry. I don't know why that happens. Okay, but yeah, these are essentially the things that you need to conduct a PDA test. You need the hammer, you drop hammer. You need your auto level to measure the pile set, meaning how much the pile settled after each blow, how much the pile went down after each blow, because that tells you about the capability of the pile to carry more load, or otherwise. And then, of course, you need the crane this time to carry the hammer and drop it onto the pile. So essentially, that's what the PDA test is. Okay, so let's go to the next slide. It doesn't want to go to the next slide. Okay, there. Oops. Why does that happen? So, okay, these are just photos of us risking our lives. And if there's any safety officer here, please do not report us. But this is for the love of the country. We're testing piles on a bridge somewhere in Davao, and the only way to test it is to access the pile this way. Of course, well, let's just skip this one because we are just showing concrete quality that is not so good and concrete quality that you wouldn't want to have when you're conducting a PDA test, because conducting a test in these conditions wouldn't give you any good result. I wouldn't even proceed to doing the test in the first place if you have poor concrete quality. Okay, so one of the things I guess that you have to value is the excavation and the pouring records when you're constructing a board pile. So because you want to document certain things when you're constructing the board pile. So one of them is the excavation records, meaning what are the soil layers you've encountered as you drill the hole up to your target depth. And so you have to, it's better to record that. And you can also cross-check this with your geotechnical report if pretty much they tell you the same thing of what type of soil you have. And of course, the concreting records, the pouring records. Pouring records, basically, you have to document, of course, the time. The time is what's important here. The time of the arrival of the concrete truck, the time it left the batching plant, the time it started pouring, and the time it ended pouring. And so you want to do that for all the trucks so that you can monitor, because as we know, concrete cures 2-3 hours, then your concrete has fully cured. And of course, you don't want that when you're constructing a board pile. You don't want your concrete to be cured in the middle of the construction of a board pile. That's a disaster. So that's one of the things you don't want to happen. And so that's why it's important to document it. It's important to document. If there's one thing I want you to take away from this seminar is if you get assigned to a project and you have board piles, you wanna pay attention to the concrete pouring records. You wanna pay attention to the timing of the concrete trucks arriving and pouring their concrete. Okay, earlier my father has mentioned about the wave equation. Basically, the wave equation really is in this context, it helps you determine whether if you're using driven piles for your site, there's a software where it uses the wave equation and it tells you, it basically guides you how easy you can drive the piles at your project site. Okay, so it's basically just a tool to help you sort of know what to expect when you're driving piles. I think I have limited time, so let me skip this and go to the important part, okay? So here, I think this is the important part. Sometimes we have an expectation about the site. For example, if now we're going into driven piles, meaning these are the piles that we install at the site, made in the factory and installed at the site. So sometimes you have certain expectations about driving the piles, meaning sometimes we expect the pile, for example, if we have a 20-meter pile, we expect that pile to be driven onto the ground or into the ground 20 meters. And that's our expectation. But sometimes reality would have it otherwise. Sometimes, why? You might ask me why. So sometimes there are certain cases where you expect that you're able to drive the pile 20 meters onto the ground or into the ground, but then in reality, you can only drive it up up to 10 meters. And it's this term they use as refusal. They use this term as refusal kasi refusal na. Ayaw na. It's no matter how hard you hit it, it's just not going down. It's refusal already. And so, is it really so? Let me ask you, what does refusal mean? I mean, this is a very loose. I mean, this word is used very loosely, you know, because what does refusal mean? How can we define refusal? And I don't think I should go into that because this is going to take a lot of time. But essentially, what the wave equation analysis program is that it helps you predict the behavior of your pile so that you don't have surprises when you're actually driving the pile. Because the last thing you want is if you have 20-meter pile and you're supposed to that's what you're supposed to do is to drive the piles 20 meters into the ground, and in reality you're only driving them 10 meters, then that's what you want to avoid because you're not meeting the objectives essentially. And so that's what the wave equation analysis program is meant to address or is meant to answer. It gives you a guide of what to expect, and by having that guide, it tells you also what equipment to use, what hammer to use, what is the appropriate hammer, and it even goes down to telling you what should be the drop height, what should be the drop height, what should be the efficiency, and all those things. So maybe that's for a different discussion because I only have 15 minutes left. So Doc, if my time is up, just let me know. So yeah, I'll just keep continuing. Okay, so I think we're almost 5 minutes more. Okay, so static load testing. I think this is especially the veterans here, the seasoned professionals here. I'm pretty sure you've encountered static load testing. So this is the oldest way to test the pile. Essentially, what you're doing is you're putting a load, you're putting a certain load on top of the pile. And by doing that, you're essentially answering the question of how much load my pile can carry. So if I put 10 pounds on top of my pile, and then my pile seems to have the ability to carry it, then I can say that my pile can carry 10 pounds. So essentially, that's what the static load testing is. And so we have different methods, of course, for testing with the static load. We have the Kent ledge or the dead weight, which is what I have described earlier, which is you just put the weight on top of the pile and measure its movement. Or you can do the reaction pile. So this is the dead weight. Basically, as you can see, that's a lot of weight blocks. And then this is the reaction pile. So when you have a reaction pile, you have your test pile in the middle and then the reaction pile on its periphery. So what happens is you pull up the periphery and push down on the test pile. So these are just two different methods, but essentially they're the same. And of course, we have the lateral load test. Lateral load test is essentially the same, except that you're pushing the pile sideways. You're applying the lateral load, essentially. Of course, the output would be the load displacement curve, as we know. And then, sorry, let me quickly discuss also because there's three types. There's the compressional test, static load test. There's the lateral, and then there's the tension. Tension meaning pulling up. It's a pulling up motion. So those are the three kinds of static load tests. The setup for the tensile test is pretty much essentially the same as the compressional, except that you're testing it in the opposite direction. Okay, and then the last segment would be probably, I think I can make the time limit. So as you can see, it takes a lot of setup for the static load test, right? I mean, if you were to conduct a static load test, imagine I only have one test pile, but I have to make 4 other test piles around my test pile. Sorry, I have to make 4 other reaction piles just to test one test pile. If not, then I have to mobilize or I have to stack up all the loads just to test my test pile. And you can see the safety implication of this one. So the bidirectional static load test actually is meant to replace those old methods and make our lives easier. And I think it's pretty much reflective on this picture. So actually, we're conducting a static load test this picture is actually conducting a static load test, a compressional static load test. Okay, so as you can see, the setup really entails just the pile and the reference beam, and that's it. So that's what the bidirectional static load test is. I don't think I have enough time to go into detail on how this is installed and how this is and the finer details of this test. But essentially, okay, hold on. There's a question here. Driven piles alters the in situ characteristics of the soil. Yes, correct. How does this affect the geotechnical analysis based on borehole tests such as SPT and CPT? Okay. So yes. So when you have driven, maybe we should just answer this on the question and answer so that I'll just finish this. I'll just finish the bidirectional test and then we can go to that question. So the bidirectional static load test, what we do is we embed this, what we call the bidirectional cell onto the rebar cage. By the way, this is a board pile. We do this test for board piles, okay? So what we do is we embed this yellow device, and this is what helps us conduct the static load test for that pile. Okay, it's quite a ingenious way of doing the test. So yes, you install that on the rebar cage, and then we have a hose that connects to this yellow device here, and it connects to a water pump. And so when we're testing, what we're doing is we're filling this up with water and making it expand, and thus applying the pressure or applying the force. Okay, so that's the method in which we test the bidirectional test. And as you can see, the test setup, this is another photo of how we're conducting the test. It's very easy. It's just the pile itself and the reference beam. And that's it. You can test any amount of load that you want. No, it doesn't have a load limitation, and it's easy, it's safe. So that's why we've been doing this test. We've done this test in several projects already here in our country. And of course, you can also embed strain gauges on your pile, and the strain gauges would tell you the resistance, the soil resistance distribution that you have at that point in your project site. And this is an information, I guess this is a valuable information for those who want to value engineer and save some money, save some cost on their foundations. So yeah, okay. I guess that's pretty much it. Let's go to the question and answer segment.
Unmute. Okay, so before we go to the question and answer portion, I just would like to thank Richard and Justin for being our resource persons today. So I've gone through, I'll ask first Eric. Eric, should we proceed? Eric, should we proceed with our, okay. So I summarized some of the questions over here. One of the most, I think the most common question people are asking, Richard, is what is the percentage? What are the percentages for piles to be tested? Let's say for the CSL, the PD, the PDA, and then the PIT.
Yeah.
Richard.
Yeah, before we do the percentages, I think we have to know very clearly, why do you test?
Mm-hmm.
Well, it's a simple question, pero dapat isipin. Why do you test? Because magkakaiba-iba. Others would test because they want to validate the pile capacity. So, in other words, if you have 100 piles, they would test maybe 3 or 5, validate the pile capacity, and then they continue with the board piling without testing anymore. So in that case, I would say the testing is only to validate capacity. But there's another testing, which I think is equally, if not more important. It is the quality control of board piles. Now, if you are after the quality of the board piles, then it follows that you will test more. You will test in random. In other words, as you progress, as you do your board piles or driven piles, certainly there will always be an aberration. If you are driving, suddenly, itong isang pile na to, naging 35 meters, whereas the others is only like 25 meters. What happened? Or something else happened. The board piling is common that during pouring, something happened, late arrival of the trucks, theoretical volume does not match the actual volume. What happened? So these are quality issues. Now, are you testing for quality as well? When we say testing, medyo mahabang sagot ko, we have to understand what is your objective. And there's another objective which Justin already mentioned. It is about value engineering. Because since you're spending money already, I think the client, the designer should get the most benefit out of the testing. What I'm trying to say is if you, for example, get the information well ahead of time, maybe you can redesign the piles to save some more money. Or if not, maybe the piles are very short and you probably need to make it longer. While you did not save money on the piles, you probably save money on the entire building. Now, just to give some numbers, indicator piles, I would say indicator meaning these are just the piles that you test well in advance. Normally it's about 3%. And then if you're talking about quality control, maybe you do more integrity testing because by then you already more or less know the length of the pile, you more or less know already the variation in the pile. But for example, Hong Kong would test 100% CSL, no question. So it really depends. And then I can also put forward an idea like testing is actually buying the confidence of the designer, most especially the structural engineers. So the more confident they become, I think they will be more amenable to have lower safety factor. Because you can always do a project without testing and adopt the safety factor of 5. Bahala na. Certainly, there will be some bad piles. Pero sa dami nila, tatayo pa rin yan. Tama? So, you have to strike the balance between, I would say, testing more and lowering the safety factor maybe from 2.5 to 2.25. Ano pang benefits sa'yo? Everything becomes economics. I hope I answered the question.
Okay. Quick. For the bidirectional test or the O-cell test, you can still use the pile or the board pile after the bidirectional test, right?
Correct.
All we need to do is grout there's some grouting that needs to be done.
Yes. It's actually done through the instruments that we install together with the bidirectional test. So we have some tubes there that we can access for grouting if you intend to use it as a working pile.
Okay. So next question is there any maximum height of the drop in a PDA?
Okay. Okay, I'll answer. So actually, the drop height is there. Well, to be honest with you, you can drop the hammer as high as you want, but the question is it necessary? Okay. So and this is always a question that's being asked, especially in the field. What's the drop height? And my answer to that is it depends. Sorry to give you a disappointing answer, but the answer to that is it depends because, again, when you're testing, you have a certain objective. And, of course, dropping the hammer very high also has safety implications. Of course, it's not safe to drop, let's say, a 40-ton hammer 3 meters high. You know, that would be very unsafe. And so the drop height really depends on the data that you get. So what I actually do, just to give everyone a background, what I do is in the beginning or my first drop, I adopt a very low drop height. And I do this, my objective for my first drop is just to test if everything is working fine, and to get an idea of the values that I'm getting. Because as you test all throughout the years, you're gonna have an idea how to adjust the drop height in terms of how you want to meet the objective. Because of course, the higher the drop height, then the stronger the energy of the impact, and the stronger the energy, then the more resistance your soil will give you. And of course, when you're testing with the PDA, you want to confirm that resistance. What's my resistance? Like, how much capacity does my pile have? Okay, and so of course, you don't want to drop the hammer too high because you can also damage the pile. And so again, everything depends on what my PDA machine tells me, the numbers, because in your PDA machine, what's reflected there is more or less the rough capacity that you're getting, and also the stresses of your pile. So what I do is I drop it at a very minimal height in the beginning so that I can have a sense of how far can I still push the drop limit.
Okay.
So again, I can give you an answer. It's a case-to-case basis.
I have a short answer to that. The limit of the drop height is the stresses in the pipe.
Okay.
I think the compression stress will be reached when you get to around 3.5, 4 meter drop height, which is already very dangerous. So you have to play around with the cushioning, drop height. That's where the wave equation also would come into play. You can perform a wave equation well ahead of time to check on the stresses and to determine what drop height would I be needing when I go to the site.
Okay.
Okay, sorry. There's a question here. Maybe you can give some recommendations on drop height. Is there a maximum? Okay, drop height will depend on magnitude of load test. Yes, using ENR formula, you will determine the drop height. Okay, yes, using the ENR formula might give you an idea, the theoretical drop height, but of course, in reality, there's energy losses. There's, of course, friction when you drop the hammer. It's friction onto the frame, and of course, the efficiency of the energy transfer. So like I said, even though we have all these formulas to sort of give us an idea, it's still the actual values you're getting during the test. That's why it's important that the tester knows what they're doing, is aware of the stresses that your pile is experiencing for that drop, because the last thing you want to do is to damage the pile when you're testing with the PDA test.
Okay, so going to the ENR, since we're already there, what's the advantage of the WEEP versus the ENR?
Okay, can I answer that?
Yeah.
Yung mga dynamic, the so-called dynamic formulas like the ENR, the highly, I think there's more than 10 or 12 popular dynamic formulas being used. Especially, I think, nag-umpisa yan 1900, meron na tayong dynamic formula. At that time, they're using timber piles and some kind of drop hammer. Dynamic formulas still being used in the 80s and even in the 90s. But you have to understand that the basis for the dynamic formula is not really correct. This is based on the momentum equation of two balls hitting one another. In reality, in pile driving, okay, the hammer can be modeled as a mass, but the pile, because of its length, cannot be modeled as a single mass. It has to be modeled as an elastic member. So that is the difference between wave equation and the dynamic formulas like ENR and all the others. If you check the dynamic formulas, you would see that the safety factor being used then was very high. They're like 4, 6 to 8 safety factor. No? This is because of the uncertainty. No? Without dynamic formula, there's no way for any engineer to have a handle of how much capacity you're getting. Somehow, the engineers will have to get an S. That's the only reason why you have this kind of formulas. Now, the, so my point is there's no comparison with the dynamic formula and the PDA that being done now. In fact, in some, I think in many countries, no longer in use.
Okay. Can I also
Okay.
add? Can I
Yeah.
also? Can I just quickly add? So,
Okay.
so yeah, the engineering news actually, all these equations, like what my father has mentioned earlier. For example, the Hailey formula, Gates formula. Yeah, one of them is the engineering news. They assume, like what my father has said, they assume a rigid pile model as I would describe it. It's two masses basically hitting each other. That's the rigid pile model. But in reality, piles actually behave more like a spring, believe it or not. Meaning, are you guys familiar with the toy, yung slinky toy? The one that and you have like bounce around. It's made into spirals and it's kind of like bounces around. A pile actually behaves in that way. If you have a slinky and you kind of jerk it, you're gonna see a wave, right? You're gonna see a wave travel down that slinky. That's basically what a pile is. It's just hard to imagine because we think that the pile is made of concrete. But if you slow-mo everything, and if you hit that pile, it actually behaves as an elastic member. Okay, it's basically like springs put together. And so that's one of the, I guess, advantages of the wave equation over the other equations, such as the engineering use, is because with the wave equation, you assume the pile to be an elastic member. And aside from that, you also consider the hammer that you use with the wave equation. And so the other equations don't consider the hammer. And to me, the hammer is very important. It's part of the equation. So that's it.
Okay. I'll go through some of the other questions. So one is, are there any other alternatives to driven piles and board piles? I think Richard asked me to comment on this. I think for the driven piles, there's a pushed in place pile, or there's the jack pile. So if it's just the vibrations that you're worried about, the jacking in place or the hydraulic pressing in place.
Yes, the static driver, as we call it.
Yeah, but then if there are other reasons, I think they might consider ground improvement procedures to be able to take this place. But Richard, can you think of any other solutions? Because I think this person is asking, medyo mahal ang board pile, pero the pile driving might not be feasible. Maybe because one of the vibrations, but maybe two, because there are, let's say, boulders inside the
property.
Under the subsurface conditions involved inclusions of boulders.
I agree with you. Like other than piles, you can do soil improvement, jet grouting, maybe stone column, depending on the loads. I think there are a lot of factors that you have to consider in arriving in the optimum foundation solution. I think this question is too
Broad.
general for us to be able to give you a very definite answer. No?
Okay.
Okay.
Okay, so if you have a board pre-boring in a driven pile, does that mean that you neglect the skin friction? So I'll go to ask the question, can pre-boring be modeled using the WEAP method, wave equation analysis, prior to driving of the pile? So you can come up with some sort of estimate of the pile capacity?
No, in the WIP, one of the input there would be the skin friction. In fact, in the pre-board file, the main issue there is what is the skin friction that you will be adopting, because it no longer is a completely fully displaced pile compared to a pile that is driven into the ground.
Okay.
It's a tough question because I don't know why you want a pre-drilled pile. Is it because of vibrations, or is it that you cannot drive into the ground?
Okay.
Okay, I think, Doc, you're...
Such project.
Sorry, go ahead.
Okay.
Yeah,
Okay.
because there was, we had one such project that the design was driven pile, but during driving, they were not able to drive the pile. That's why they opted for a pre-drilled and then put the pile instead.
Okay. Yeah. Okay. I think we've answered there. Some of the other questions is which is more economical, board pile or driven pile? Really depends, because if, let's say, you drive it and then there are a lot of excesses because you're not able to drive, there might be a very high amount of wastage. So it's not really an apples comparing. It's more like comparing apples to oranges.
Yeah. Sometimes it's also the environment that dictates what is more economical or what is possible. If, for example, you're in Binondo and we know that the streets are very tight. So how can you bring in the driven piles into your property? So it's sometimes also the environment. There's also one question here that I'd like to answer. Do you need to verify the results of PDA with static load tests, given that static load test simulates the real load of building? Actually, yeah. Back in the day when PDA was still in its infancy stages, I think this was in the 1950s, if I'm not mistaken, or 60s. They already did this, of course, proving that PDA is as reliable as static load tests. And there's also a lot of materials actually online, research papers that compares the results of static load test and the PDA test.
Okay. I think I'll ask Richard this. There's still a benefit to doing a PDA. You can do a PDA on a pile that has undergone static pile load test, right? So that you can correlate the two.
Yes.
Okay.
Mark, we have done, I think.
Yes.
I have done quite a number of projects wherein we did static and PDA for correlation study.
Okay.
One of that is the Santa Rita Power Plant in Batangas, wherein we did static and PDA on the same piles to prove the accuracy of the PDA.
Okay.
Static testing is the gold bar of testing. Okay. However, you cannot do so much in a given project because the setup, the preparation, and everything, it's very costly. And also, the information you get from static testing is quite limited. If you just do a top-down load, all you see is the
load settlement.
Yeah. Now, PDA, I think for the same amount of money, you test maybe 10 or 15 times more piles in a lesser time frame. Maybe you test in 2 or 3 days. Whereas if you do one static, you probably need 3 weeks to 4 weeks for one test.
And sometimes
to get a
the reaction pile.
I did not get that again.
You also have the cost of the reaction pile in most, unless you do a Kent ledge.
Yeah, and also static testing is being done on a selected pile for a project, whereas PDA you can
be
test
done randomly.
So you more confidence doing the PDA.
Okay.
It's more convenient. Okay. You save time, you save cost, and you get more information because you know the capacity, you get the integrity of the pile. If you have a damage, you'll be able to evaluate where is the damage, what is.
Okay.
Hope I think he got cut off.
Okay, so but then Justin, how long
Yeah.
after how long you have to wait for you to be able to do a CSL on a board pile?
Oh, a very good
After
question.
pouring.
Okay, that's a very, very good question. Normally, you would want to wait for the concrete to cure, to fully cure before doing a CSL test. The reason
Mhm.
is because, again, the CSL test, this detects any change in material. So while you're still in that curing stage, imagine your entire pile is in the middle of changing its state to a fully cured concrete. So the risk of doing a crosshole test while the pile is still curing is that you might get results that would tell you that the pile might have some defect in it. But then in reality, it can also be that it's because of the pile still curing. So when you test the pile at an early age and you encounter signal losses, signal delays that would tell you that there's something wrong, now you're guessing whether it's a real defect or is it just my pile curing. And so the consequence of that is you come back at a much later date and retest it and see what happens. But of course, we have tested piles. We've actually tested piles 3 days old, 7 days old, 11 days old. And we actually, we tested the same pile 3 days old, 7, 11, and we had the comparison. And that was, of course, you would see the signal improving as it gets older because the concrete is more cured at the latter date.
Okay. Richard, is there a factor of safety? Let's say like you test a PDA pile by PDA and you get an estimate of the ultimate load or the mobilized load. Is there any recommended factor of safety for that?
The normal global safety factor would be about 2.5.
Mga 2.5. Okay.
I think you can lower down the safety factor if you test more because the
Okay.
uncertainty test, diba? But
Mhm.
did I answer?
Yeah, okay.
So that's about it. I mean, safety factor normally lies in the hands of the structural, although we for a well-tested project.
Okay, so for static, di ba, it's 200% of the design or the working load. For
Yes.
PA, what is the percentage? Is it also twice?
Yes.
Okay.
Actually, it depends.
Go ahead.
Okay, yeah, sorry. Actually, it depends again on the designer. It's actually the same. If you're testing with PDA, one of your objectives is to reach the ultimate or the required ultimate capacity of the pipe, which is set by the designer. So sometimes some designers adopt a safety factor of 2, meaning if they have an allowable of 1,000 tons, and if you have a safety factor of 2, of course, you have 2,000. And so during the test, that's what we want to achieve, is the required ultimate. So it really depends on the designer. Of course, some designers, they adopt 2.5. Some adopt 2.25, but that's the usual range, between 2 to 2.5.
Okay. Question here is, when you have spliced piles, you can use both the PIT and you can use also the PDA to some extent. I think the PIT, which is the best to use for if you want to check if there are dog legging and those types of things in the pile, in a driven pile.
Okay.
That's spliced.
Okay. Okay, yeah, let me answer it. Actually, so the question is which test method is better, okay? So if you're only talking about the integrity of the pile, because your concern is if it has dog legging, meaning it's not in a vertical position anymore. So I would say that the PIT is enough because the PDA, the PIT is a good integrity test. It would tell you any major breaks in your pile, especially for a driven pile. If you have a major discontinuity on your pile, then the PIT would be a fast test, a quick test, and also an economical test. So I would say for that scenario, that would be the PIT. Again, the PDA can also tell you that, but of course, PDA takes much more time to set up and it's more costly than the PIT. But the advantage of the PDA is that it gives you the capacity, how much load my pile can carry.
Okay. I think there's still some questions here, but I think we can answer them afterwards because it's almost very, very close to 5. So with that, we promise those who submitted questions that we will reply to them. So with that, I'd like to turn back the floor back to Eric.
Oh, sorry. Oh, sorry. Can we add? This is actually a good question. Sorry, last question because
Go ahead,
this was the first question I mentioned earlier, and I'd feel bad not to answer for us not to be able to answer. So the question from Mr. Angelito was driven pile alters the in situ characteristic of the soil. Now, how does this affect the geotechnical empirical analysis based on borehole tests such as CPT and SPT? Okay, I'll let my father answer that.
So throughout the years, there is already an established correlation of the N value with certain engineering, the technical parameters, the strength parameters, and based on that, you predict the pile capacity. In fact, that's a good question because in board piles, you don't have the same kind of installation because you replace the soil with the concrete because you bore first and then you put in the concrete. In the driven pile, you displace the soil with your pile. So just imagining that, you would already know that driven piles will have more skin friction than compared to board piles. So given the CPT value or the SPTN value, the skin resistance that you expect from a driven pile compared to the board pile will be different. I would say at least you have 2 to 3 times skin friction of driven pile than the board pile.
Because you're improving the soil as you drive the pile.
Yeah.
Plus, if it is coarse grained with sand, that densifies with the vibrations. Even the vibrations already densifies the soil. Yes.
Now this is only for the skin friction. For the end bearing, I would trust more the driven pile than the board pile for obvious reasons because board pile has a lot of imperfections, especially below, say, 2-3 meters. And that is exacerbated if you have very long pile, like more than 30 meters, 40 meters long piles. It is so difficult to clean up the bottom and rest your concrete on the intended, let's say, bedrock or foundation. More often than not, you have dirty concrete, you have soil inclusions, or you have bad concrete at the bottom of your pile. And this does not happen to driven pile. The only drawback of driven pile is you cannot embed it into the bedrock. Unlike board pile, wherein you can drill as you wish, and embed your pile.
Okay. Okay, so I guess that closes. Yes.
Can I say something also?
Okay.
Just words. Sorry, Mark. While we talk about testing, we should also talk. I think we have already talked about why do you need to do the test, but we have not discussed who should be testing. Who should be testing? Globally, there is a website that you can go to look for people that are qualified to do the testing. In the olden times, people can buy equipment, do their own testing, but there's no, qualifications or there's no training that come with it. It's like buying an airplane and you have trained your pilot and then you want to trust your life with it when you fly. So I would say if you want to do an honest to goodness testing, look for qualified people, look for people that has credibility to do the testing because that is, I think, very important. Ang masamang nangyayari kung minsan sa ating industry is somebody doing the testing, and then because of the results that is not favorable to, say, a contractor, in the middle of the game, it would say, okay, let's change the tester. Maybe I need to do another, to get another testing company. So parang nagiging whimsical in our practice. You know, I can liken this, tayo lahat nanonood siguro ng basketball and we have referees. Have we ever encountered that in the middle of the game, we change referee because we don't like the referee's calling because he called on my guys, the fouls, he called on my guys and all that. And so now I say, stop the game, let's change referee and go on. This should not be the case, no? We want to professionalize our testing industry. We have to qualify the people that can do the test, and we should avoid yung ganitong nangyayari sa industry. That's all I can say based on my experience.
Okay. So I turn it over to Eric. Back to Eric.
Thank you, Doc Zarco. Thank you. And to our speakers, Sir Richard and Sir Justin, thank you very much.
Thank you.
Actually, definitely we will be inviting you again for, I think marami pa tayong gusto i-discuss sa Geotechnical. Even me, I'm a geotechnical engineer and I've learned a lot. Tsaka kasi sa Geotechnical, ang daming uncertainties. Laging kasi sabi nga, pag nakabaon na sa lupa, wala nang pakialam yung So it's a good, that's why I can see there's a lot of questions being raised because yun nga, there's a lot of uncertainties with regards to geotechnical engineering. So again, thank you to our speakers. Definitely, antayin nyo po, mag-i-invite po ulit kami sa inyo sa webinar natin. Thank you, Sir Mark.
Okay.
So just a few announcements lang po before I turn it over to our President. So again, after this po, the evaluation form will pop up on your screen. Please fill it up and submit. Certificates will be and materials will be posted or uploaded on the PICE website after the last day of our webinar series, which is on June 19. Our next webinar will be on Monday again. So this is in Environmental and Energy Engineering, 3 p.m. So those who have registered, so yun po, save the date. It's Monday, 3 p.m. to 5 p.m. po ulit.
Okay.
Yun lang po. So thank you again, Press Bong, for the closing.
Yeah, Sir Eric, thank you very much. So, kamusta na po tayo? Grabe, no? Overload of learnings really this afternoon from the very informative and interesting session. Yeah. Hearing from our father and son experience experts pa talaga. And our panelists on piles and pile testing, you know. So the knowledge on the topic is very, very important really to us in our practice. So we really are very lucky to be part of the session this afternoon. At this juncture, I would like to express our profound gratitude to our resource speakers, Engineer Richard Dunn and Engineer Justin Dunn. Sigurado mag-invite na naman uli yung PICE. No? And of course, our panelist moderator, Dr. Zarco, sir, thank you very much.
Okay.
Our ISG chair, siyempre, grabe, no? Si Eric. And of course, andyan pa si Ma'am Proxy. Ma'am, thank you for the all-out support to our webinars and to the PICE.
I just thought Richard will say something he told me a long time ago. He said, "Ma'am, factor of safety is just factor of ignorance." Thank you.
At least now, maybe kung magalit si ma'am, kaunti lang kasi mas marami sinabi yung anak ko kaysa sa akin.
Thank you to everyone. And of course, to the PICE National Board of Directors, the Secretariat, kahit holiday, andyan sila. No, of course, Davis Paints, our sponsor, and to all our members out there, a big hand of applause to all of us. No?
Okay.
May clap ata dyan sa Zoom screen, or you have thumbs up or like naman dun sa ating FB page for this very, very successful session this afternoon of our webinar series. But of course, again, I'd like to reiterate our announcement dun sa membership portal ng PICE. So I would like to encourage you all, our PIC members, either you are a fellow, a life, or a regular member, to register or refer members. You can refer a member in our ongoing membership information update campaign. So this campaign will be up to June 30, 2020. Pero diretso pa rin to, But just log in to the link provided in our PIC National Facebook page or Facebook account, or at the website. You can see also the link there, or you may contact your chapter officers. So just update your profile in our membership portal database so that PIC National can contact you and can serve you better. So by successfully registering and referring, pwedeng mag-refer ng members during the campaign period, you can even win prizes. May prizes tayo during the campaign. If you're lucky, we have weekly and grand draw. Parang iPad ata yung sa grand draw. So this June 30, it is free. Wala pang babayaran to register. Yung mga fellow, live, tsaka regular members, wala pang babayaran during the registration ngayon. But for civil engineers who would like to join PICE, yung mga hindi pa nag-join to PICE, you may also click the link, fill up the registration form, and pay your initial dues. Kayo lang medyo may bayad ngayon. Better act and register na ngayon during the campaign. Okay? So lastly, let us always remember, yung sinasabi ko noon pa, that we should be holy. Don't forget to pray always. Healthy, be safe, and follow the protocols of government. Yung social distancing, wag muna mag-date-date, And andyan si Edie, nakalimutan ko, si executive director natin sa PICE. Sinabihan ko kanina, pwede na siya mag-date. But wag muna pala. And of course, be happy. Smile and enjoy life always. Let us value the learnings and the blessings that our Almighty has bestowed on us every day of our lives. So, lastly, at sa araw na ito ng pagdiriwang natin ng ating kalayaan, naway isigaw natin sa buong mundo na tayo'y Filipino and a proud Filipino civil engineer. Mabuhay ang ating bansa, mabuhay tayong lahat, mabuhay of course ang PICE. Maraming salamat po. Magkikita tayo uli Monday for another session of the PICE free webinar lecture series. God bless us all. Salamat kayo sa tanan. Thank you very much.
Salamat, sir.
Sige.
Thank you po. Thank you po ulit. Thank you, Fred. So, happy Independence Day. So please fill the evaluation form. Thank you. Stay safe.
Sige.
Bye.
Bye-bye.
Thank you.
Okay, let's see. We'll see.